Okay, so you're here because you want to see me derive the time dilation formula from this. Okay, so let's do it. The ship is traveling at some speed v, right? This total distance from here to here is vt, right? And L then therefore is half that distance, right? So I can substitute that equals L. I can substitute that in for L, so let's do that. So now we have the dilated time is equal to 2 square root of d squared plus, and then this is vt over 2, and that whole thing is squared, right? And then this is divided by the speed of light. Okay, now the next thing I'm going to do is I'm going to multiply. I'm going to go this times this down there. I'm going to put that down there, and getting the radical by itself. I'm also going to, because I don't have much space here, I'm going to square it at the same time, right? So c up there, so ct over 2, square both sides, and you get this, right? And now the radical goes away. This is a radical notion. So d squared, jeez, it's my pen. I hate this thing. Plus, okay, v, t, you gotta draw slowly. Okay, now obviously I think the thing to do is to get the things with t on the same side, right? Okay, so let's do that. Now we've got c t over 2 squared minus v t over 2. This little Mac is really not handling this very well. I thought Mac errors were fast. Squared equals d squared. Seems to be going slower and slower. Okay. Now the thing to do, I think, is to factor ct squared over 2 out of both of these sides. Now, of course, I know this because I know what the answer should be, right? Okay, so now we've got ct over 2. God, look how slow this thing is, squared. Right, and then I'm going to, if I factor that out, of course, this is 1 minus, and then this, of course, everything goes away, right? The t squared and the 2 squared, but we get v squared over c squared, right? So v squared over c squared, you gotta draw that very slowly. And that equals d squared, right? So many squareds. Okay. Now the next thing to do is to actually, I want to get this t by itself. So what I'm going to do is I'm going to multiply, I'm going to put the 2 squared up here, the c squared below that, and then I'm going to divide by this thing in parentheses there, right? So I've got t squared equals, and then so I've got on the numerator, I've got 2d over c, that whole thing squared, over parentheses 1 minus v squared for c squared. It's going very slowly. Okay, so now if you look at this, do you see that 2d over c, that's just the proper time squared in the numerator, right? Okay, so if I square root both sides, and I substitute this guy, right, if I substitute that guy, in for that, right, I get, this is a great moment in physics, if I square root both sides, I get that time, the dilated time, equals, well, this is the proper time, right? I'm substituting that in for that, right? All over minus v squared over c squared. Thank you for putting up for my very slow bamboo pen. Why is it being so slow? It's faster on my MacBook. Maybe I need to reinstall the driver or something like that. I just don't know. All right. So there it is, right? It's this t equals t squared over the square root of 1 minus v squared over c squared. Okay? You look at that formula and you can see that this thing is always going to be a little bit less than 1, right? If that's 0, then of course this is 1, that time equals time if we're not moving, right? And as we approach the speed of light, this thing in the radical, thing inside the radical approaches 0, and so the dilated time approaches infinity. That is, as you approach the speed of light, we see your clocks take an infinite amount of time. It approaches infinity to tick.